Two pieces of the same type of metal touch in space. They will bond and be permanently stuck together. This phenomenon is known as cold welding or contact welding, and it occurs in the vacuum of space. In this welding method, heat is not the primary element for fusing metals. Instead, this happens because in the vacuum of space, there is no air or water to form an oxidized layer on the metal surface. On Earth, this oxidized layer prevents metals from bonding without significant heat or pressure. In space, without this layer, when two pieces of the same kind of metal come into contact, their atoms can't tell that they are separate pieces of metal, so the lumps of metal will join together. This can happen with any kind of metal, though it is more likely with softer metals. This effect was first observed in the 1940s, but was widely recognized during early space missions. Cold welding is not as common or as easy as it might sound. The metal surfaces must be very clean and smooth, and in some cases, this type of welding will not occur spontaneously. This technique is particularly suitable for wire joining and has been utilized in space for bonding metals. Spacecraft designers are aware of this issue and typically design components in a way to prevent unintentional cold welding. This welding method finds diverse applications across various industries due to its distinctive process of joining metals without the need for heat. Scientists have discovered a new type of matter called time crystals. Unlike traditional crystals, like the solids, liquids, and gases we're familiar with, time crystals don't have a physical shape. Instead, they have atoms arranged in patterns that repeat not only in space but also in time. It's like a crystal that constantly flips back and forth between different states without using any energy. These time crystals exist at incredibly small scales and extremely low temperatures. They can only be observed under special quantum conditions, where atoms and their particles interact. Creating time crystals involves cooling helium gas to an incredibly low temperature while carefully observing its behaviors. At such low temperatures, matter behaves differently, and quantum effects dominate. Time crystals exhibit oscillations between different low-energy states, creating a perpetual, indefinite motion. Time crystals do not violate thermodynamic laws, nor constitute perpetual motion machines, as they require external energy inputs. While time crystals may not serve any practical purpose yet, scientists believe they could be used as a memory for quantum computers in the future. Studying time crystals helps researchers understand the mysterious world of quantum physics, where particles can exist in multiple places simultaneously, form quantum-encoded information bits, and exhibit phenomena like entanglement and teleportation. Which country will be the first to land a human on Mars? 3 nations are competing to put a human on Mars: the US, Russia, and China. Each of these nations has its advantages. The US with its technological innovation and public-private partnerships, China with its rapid advancements and strategic long-term planning, and Russia with its historic expertise and proven track record in crewed space exploration. While the US currently leads in Mars-relevant technologies and experience, China's swift progress and integrated approach, along with Russia's historical know-how and ongoing efforts, make the race to Mars an open and dynamic field. The United States, with its long-standing legacy in space missions, including the Apollo moon landings and the Mars rover explorations, has a wealth of experience and technological prowess. NASA's Artemis program, aimed at returning humans to the moon as a stepping stone for Mars, and partnerships with private companies like SpaceX, which is developing the Starship spacecraft specifically for Mars missions, underscore the country's commitment and innovative approach. On the other hand, China's rapid ascent in space technology, marked by the success of its lunar missions and the establishment of its own space station, demonstrates its capability and determination. China's space program is driven by state-backed funding and a long-term strategic vision, embodied in the Chinese space station and the Chang'e lunar exploration program. Lastly, Russia, with its rich history in space exploration dating back to the first human in space, Yuri Gagarin, and the launch of the first satellite, Sputnik, has a deep-seated expertise in crewed spaceflight. Despite recent setbacks and budgetary constraints, Russia's well-established space infrastructure, skilled workforce, and experience in long-duration space flights, as seen in its Mir space station and participation in the International Space Station, provide a solid foundation. Russia's Soyuz spacecraft has been a reliable workhorse for crewed missions, and developments like the Angara rocket and the proposed Oral spacecraft could bolster its capability for interplanetary travel. The first human landing on Mars will not only be a monumental scientific achievement, but also a testament to the leading nation's strategic vision, technological capability, and commitment to space exploration. It will mark a new chapter in human history, opening doors to interplanetary travel and deepening our understanding of the universe.